Differentiation of trigonometric functions with the chain rule. There are 3 examples in this video. Find the derivative of cosine of the angle 7x minus 3. There are 2 layers to this function, so we use the chain rule. The outside layer is the cosine of the angle and the inside layer is the angle itself. The derivative of cosine is negative sine, so it's negative sine of the angle doesn't change. And then we multiply this by the derivative of the angle of the inside part, which becomes 7. That's the answer. We just tidy it up by writing it as negative 7 sine times the angle. Find the derivative of tan squared 3x. Tan squared 3x means tan of 3x to be squared. There are 3 layers to this: the power, the tan, and the angle. The outside layer, multiply by the power, reduce the power by 1. So it becomes 2 times tan of 3x, all to the power of 1. Now we multiply this by the derivative of the middle part. Tan of an angle turns into sec squared of the angle. So it becomes sec squared 3x. And multiply this by the derivative of the very inside bit, the angle itself, which is 3. That's our solution. We can neaten it up because 2 3s are 6. In the next example, we have sine cubed of the angle x squared plus 2. Again, there are 3 layers to this, because this means sine of the angle x squared plus 2 all to the power of 3. The outside layer is the power, the middle layer is the sine of the angle, and then the angle is the very inside layer. So the derivative of the outside, multiply by the power 3 and reduce the power by 1. So it becomes 3 times sine of the angle all to be squared. Then we get the diff of the middle layer. So sine goes to cosine, so it becomes cosine of the angle. And finally, the derivative of the angle x squared plus 2 is 2x. This is our solution. We could just neaten it a little bit in how we write it. 3 times 2x is 6x. And we could write it as sine squared of the angle multiplied by cos of the angle. And note again, the angle never changes.